Hey guys, we are going to talk about lesson 2 today, and we're going to focus on solving equations using elimination. So what are you trying to find when you solve a system of equations? So the answer to that question, we kind of talked about this yesterday, but it's finding that point where they meet. So I don't care how many lines you have. You could have one line, you could have 5 lines. I guess you need more than one, don't you? So 2 lines or 5 lines. But it's that point that they meet here. And it's in terms of a coordinate point. So the next slide, we know how to find the point of an intersection by graphing. So we talked about that yesterday. What happens when the equations are hard to graph? So this is where solving by graphing kind of falls apart, because if this point is like, I don't know, let's say 9 fourths and I don't know, 13 thirds or something weird like that. There is no way for us to get this exact point using graphing. So this is definitely where the graphing kind of falls apart. So the second way we talked about is substitution. Substitution is nice when you have one variable set equal to something. And so we talked yesterday how you plug in 3 for x or x plus 1 for y and go from there. That is a really great way when the variable is isolated. But when you have something in standard form, elimination is your way to go. And so our goal is to get rid of a variable and make sure that you have one sign positive and one sign negative. Then we're going to add the equations together and solve for the variable. And so we're going to do that on the next page. Okay, so in this slide, we have this problem. So notice that it's in standard form, so it wouldn't be very, a very good idea to use graphing because it's really not a good point to graph. There's no really nice intercepts except maybe here and here. But then it's in standard form. So we are going to add these together because I noticed one thing right there. Those are going to cancel out if I combine them. So on this side we have 7x equals 28, and look at that. So we're just going to solve for x, and x equals 4. The thing that isn't the greatest about this is that you've got to plug in this 4, and you can plug it in anywhere, but these are a little bit more difficult to plug into than substitution or something like that. So let's go ahead, I'll just take this one. It doesn't matter, again, which one you plug it in for. So 2x, which is 4, minus 3y equals 8. So 8 minus 3y equals 8. So I'm sure you're probably seeing something. That's okay. So we're just going to subtract the 8. Negative 3y equals 0. Don't forget, when 0 on top, it's okay. So that just equals 0. So when we divide by negative 3, y equals 0. So my answer, don't forget to give the final answer, is 4, 0. Okay, this might be okay with substitution because I can move that guy over, but we're going to do it with elimination. So I think the first thing I'm going to do is flip-flop these around because they're in this strange order. So I have 6x plus y equals 6. So I think what I want to do is multiply this y by negative 2 because that's going to give me the y's canceling out. So I have negative 12x right there minus 2y equals negative 12. So again, these y's cancel out, and I have negative 9x equals negative 3. So be careful, your answer is not 3. Go through that process. So we're going to divide by negative 9, and x equals 1/3. So once I have x equal to 1/3, again, I have to plug it in somewhere. So I'll just plug it in that first equation again. So y plus 6 times x, which is 1/3, equals 6. Well, if you type it in your calculator, 1/3 of 6 is 2. So I'm going to subtract 2 from both sides, so y equals 4. So my answer is 1/3, 4. Okay, so we're going to do another one. We have this problem. And this isn't a really nice problem because I have to do something to both of them to make it work. So I like how this is negative and this is positive. So I might multiply this by 4 and this by 3. That's going to give me a negative 12 and a positive 12, and that'll get rid of those y's again. So I'm going to distribute this 4 to everything. So I'm going to have 16x minus 12y equals negative 8. And here I have 18x plus 12y equals 31 times 3. That's 93. So I'm going to combine the equations, and I get 34x equals 85. I'm going to divide by 34, and if you simplify that fraction, it simplifies out to 5/2. So I'm going to have to plug it in someplace. I'll plug it into this one here. So 4 times 5/2 minus 3y equals negative 2. 5/2 times 4 is 10. So when I subtract the 10, I get negative 12, and y equals 4. So my final answer is 5/2, 4. Like that. Okay, when we also talked about this yesterday, but we're going to see it today. When the lines are parallel, you have no solution, and so it's that inconsistent answer. And algebraically, you're going to end up with something that doesn't make sense. When you have the same line, it's going to make sense, but all your variables are going to cancel out. So it's okay. We're going to kind of translate this into this year. So from now on, Algebra 2 and beyond, we are going to, this answer is not going to cut it. We're going to make it a little bit more technical. So I'll talk about that when we get to it. So let's go ahead and solve this one. So I'm going to multiply by 2, and I get negative 4x plus 14y equals negative 14. So what happens here is everything cancels out, right? So I get 0 equals 0. So that is a situation of this. It's not parallel, it's infinitely many solutions because it's the same line. So what this is saying is that we're going to put it into slope-intercept form, and that will give us the most simplified form. So I'll just take this one for example. So negative 2x plus 7y equals negative 7. I'm going to solve for y. So 2x minus 7, divide everything through by 7. So y equals 2 7 x minus 1. If you chose to do this one, you would end up with the exact same thing. So my final answer, we're going to do this in set builder notation, is xy, and then the line, that means such that, and then y equals 2 7 x minus 1. Okay, let's do one more. So I have this situation. I think what I'm going to do is divide everything through by 5 to kind of simplify that. So I have, I'll do negative 5 actually. So then I have x plus 4y equals 3. Then I might, well, let's go ahead and drop this down. So I might multiply this by negative 2. And so I have negative 2x minus 8y equals negative 6. And look what happens. These cancel out, so I get 0 equals 18. Well, that definitely is not true. So that's a case of parallel lines, and so you have no solution. And that's it.